Thanks so much. This is what a pleasure. So the concluding part of our program, our NASA program today, for this concluding part, we're going to have leaders at NASA talk about not only a look in the past, but a look forward as well. You've all heard that we're returning to the moon, or as we like to say at NASA, we're going forward to the moon. So I'd like to introduce some very special people who are here with us today who'd like to share the plans. And so I'm going to introduce them. I'll ask a couple of questions, but we really want to get all of you engaged as well. So immediately to my left, you've already met Dr. Jake Bleeksher. Jake, like I mentioned earlier, is the Chief Scientist for NASA's Human Exploration and Operations Mission Directorate. He's a volcanologist and a field geologist. He has also been a part of my institute, SURVEY, since, I think, pretty much since its inception. So he represents the human exploration side of the house. To Jake's left is Dr. Lori Glaze. Lori is the head of the Planetary Science Division at NASA headquarters, part of the Science Mission Directorate. She is a planetary scientist herself with an abiding interest in Venus, but now it's all the planets are equal. And she's in charge of a lot of super cool things like the Juno spacecraft to Jupiter, all the Mars spacecraft that you see, etc. She has the keys to all of those. To Lori's left is Mr. Steve Clark. Steve is the head of a new program at NASA, the Lunar Discovery and Exploration Program. He's also Deputy Associate Administrator for the Science Mission Directorate. He is a former director as well of the Heliophysics Division at NASA headquarters. So please welcome our distinguished guests. And so, like I mentioned, I have two questions I'm going to ask each of our guests. I'm going to start with a look towards the past, and I'll start with Jake here. Jake, how did Apollo and the other missions that you saw in your youth, how did they inspire you, and how did they shape your career path?
So I've had to think about that a lot over the last week. I've been on a lot of interviews and talking with folks on the radio, and we go through, when you're in positions like we are, we go through media training, and we learn that you need to have a key message you want to get through. And it's nice to have a good one-liner. And my good one-liner for this whole thing was, as we go forward to the moon, we're standing on the shoulders of Apollo. And there's no way that we are going there without carrying with us the knowledge, the experiences that Apollo gained for us. And by the way, I was texting with Ben Feist here and our pal Noah Petro about this, and he said, well, I'm going to start using that line. So if you hear him say that, it's my line. Boom goes the dynamite, Noah. But that is actually comes from a Isaac Newton comment about if I've seen further, it's because I stood on the shoulders of giants. And there's no other way to really think about this. We're going to the moon by 2024. We're going to land first woman and the next man at the south pole of the moon. But we're not doing that in isolation. We are doing it because of all of the space science research that we've done to get to this point. We learned the lessons about how to land robots, how to land people, how to conduct operations on the surface. So none of that's possible without this. I was talking to a few of the folks who talked two panels before us that were actually on the Hornet. And the gentleman made a comment about how it was kind of annoying to him as a 22-year-old that he wasn't getting leave, he had to be here. And I said, well, look, I'm going to do everything I can to make sure we frustrate some 22-year-olds in the future as we're going back to the moon. this time in a sustainable way.
Thanks, Jake. Lori, please.
Yeah, so on. Is this on? Yes. So I thought I would just share a little bit of my personal inspiration story, which, when Apollo flew and when they splashed down in 1969, I was around, I was alive, but not quite at a point where I was really coherent of what was going on. So while it certainly inspired me later on in my life, what really inspired me, I wanted to carry beyond just the lunar exploration program, which is why we're here today, but into additional human exploration that occurred beyond that, which is through the space shuttle program and onto the International Space Station. And in my personal story, both of my parents were engineers and both worked on different aspects of the space shuttle program, developing and working on different aspects of that space shuttle design. And to me, as a young woman growing up in junior high and high school, that was an absolutely inspirational time for me to be able to see that we were enabling a new type of human exploration. At that time, we weren't sending humans up, and we were able to send them back through the space shuttle program. And to me, that was hugely inspirational. Of course, they were both engineers, and I grew up and said engineering was not for me. I had to do something different to break the mold. So I went into a new career field that you heard David Kring talking about earlier, that during the time of the Apollo program, when the first Apollo 11 landed on the moon, there was no such thing as planetary science. The way we looked at planets was through telescopes from Earth. It was called astronomy. But with the landing on the moon, that opened up a brand new field. It actually invented the field of planetary science, where we actually now think of actually visiting different destinations in the solar system and conducting science at those locations, and that is in fact planetary science. And the lunar missions, Apollo 11 and beyond, with the samples that they brought back, as Jack was saying earlier, essentially gave us that fundamental information about how the solar system formed and evolved, that earliest part of solar system formation, the early bombardment, the way that planets came together through accretion and then were modified through additional meteor impacts, informed us about how the solar system formed and inspired us and encouraged us to explore beyond the moon and go into the rest of the solar system. And as Greg just said, I'm absolutely honored to have the ability now to work in a planetary science division that has missions spread across the entire solar system. We have missions at the moon, of course. We've had recently missions at Mercury. We now have missions all the way across the solar system, many at Mars, missions at Jupiter. We have missions all the way out into the Kuiper Belt, beyond Pluto, and we're planning new missions today that will go to new destinations and have new discoveries as we go forward. So as we look back at all of the incredible discoveries that were made 50 years ago, we're ready now to move forward with a new generation of scientists and engineers for that exploration as we go into in the future of the unknown. So thank you.
That's cool. Thank you. It's amazing how far we've come.
Yeah.
Steve?
Well, it's obvious that I'm the old man of the group because I was alive and I remember it well. On July 20th, 1969, I was 9 years old, sitting in front of a black and white TV in my grandparents' living room with my sister, mother, and father, and watching it live. I had had some inspiration leading up to that point. My dad was an Air Force pilot, so I grew up around airplanes. And he used to have Aviation Week in Space Technology magazine come to the house. And, you know, as I was younger, I certainly didn't understand what I was reading, but I was looking at the pictures. And I saw the Gemini missions unfold in front of me and the astronauts and leading up through Apollo 8, of course, you know, going around the moon. So leading up to that morning or that day of July 20th, I looked over at my dad and my dad was West Point grad, tough as nails, never showed emotion. Tears came out of his eyes watching Neil Armstrong going on the moon because he just could not believe we were actually doing it. And between his reaction And me watching it, I knew that I wanted a career in either aerospace or, flying airplanes or being involved in the space program. And so, unfortunately, my eyes went bad when I was young, so I knew I wasn't going to be an Air Force pilot and follow my dad's footsteps. But I wanted to get involved in the space program, and I felt honored to actually have the opportunity to start working on the space shuttle program. That's where I started my career. I was saddened to see Apollo didn't continue, because I thought, hey, we're going to just keep going back to the moon and on to Mars, and by the time I graduate and get my degree, we're going to be out there all over the solar system. But obviously that didn't happen, and you heard Jack Schmidt say earlier, stay flexible. Well, that is definitely a key, going through all the different programs and fits and starts, but Space Shuttle program, International Space Station, Constellation program, David talked about that, lived through that. You just got to stay flexible, and now here we are, and I'm in a position now working with these folks here and others to actually make this happen, to return humans to the moon by 2024, science being the primary driver of the reason we're going back. Not a second thought, not an afterthought, but a primary driver. And I'm actually seeing a good intersection between science, human exploration goals, and technology development. I've seen a synergy now at NASA that I haven't seen before to this level. And we're working very closely together to make the first human return mission happen. But we're also looking at doing something different. And I'm in charge of a program called the Commercial Lunar Payload Services. We have commercial companies that are developing landers to take NASA instruments and other customers' payloads to the surface of the moon. And NASA is actually buying a ride. We're not managing the mission. We're not in charge of the mission. We don't own the hardware. We're buying a ride. It's almost like a FedEx or DHL service to the moon. And it's a brand new way of doing things. And I think it's going to be successful. And it's just the start of how we are working closely with our commercial partners. We're going to be doing that in the human spaceflight side too. This is really a new era of how we're going to do space travel. So I remain inspired, and I hope everyone out there is inspired, because the way we return to the moon is going to be different. But we are leveraging what we have certainly learned from Apollo and what we've learned from our long stays at the International Space Station as well.
Thank you, Steve. It reminds me of that scene in 2001, A Space Odyssey, when the Pan Am spacecraft is coming up to meet the space station. It took a little bit longer, but I think that's the direction we're going. I wanted to share a little story myself. Steve and I found out earlier today that we were both 9 years old when the landing happened, and I actually found something. My mother told me that she had something she wanted to show me a few years back, and when I got over there, she showed me a little drawing, and what the drawing said, it was just done when I was about 6 or so, and it showed a picture of some spacecraft, and it said, when I grow up, I want to work for NASA. And so that was really weird. Been there 34 years now, but it's an illustration of what Jake talked about earlier about the inspiration. I was inspired by Mercury and Gemini, and then Apollo. It's done so much, even for kids that don't end up going to the space program, to bring them into STEM fields. So what I'd like to do now is I have one more question for the panelists, and that's, what are you doing now, you and your organization, to advance our return to the moon? And for this one, I'd like to start with Lori, please.
Great, thank you. So I think Steve just mentioned a minute ago that the importance of the difference in how we're going about returning to the moon this time and thinking forward to going to Mars. And one of the key parts of that, of course, is that the science is driving exploration, and then the exploration component is enabling more science. And there's a bug here, sorry about that. But they're working together hand in hand, as Steve says, from the outset, really thinking and working together about how we can get the most out of a new human exploration program to push more science, to get more science, enable more science, and then use that science to, again, enable more human exploration. So within our division, within planetary science, we're focused on the lunar science that we can do in the immediate future, and developing new instrumentation and thinking about what types of science do we want to do. We're working with the Survey Forum that Greg leads in order to better understand the types of places we might go and what types of science can be done there, thinking about what collections of instruments might really do some fantastic science on the surface of the moon. But we're also thinking ahead within Planetary Science Division, thinking about the next step, which is going on to Mars. And we don't ever want to lose sight of that when we're talking about this exploration program that we have now, it's Moon to Mars. We're thinking about going to Moon and then on to Mars with humans. And so a lot of the robotic exploration that we have going on at Mars right now is helping to pave the way for that future human exploration. We're not only learning more and more about the surface environment on Mars, we're trying to characterize what it's like, understanding what types of, again, potential resources. You've heard Jen Heldman talk a lot about the water that's present on the moon. We also want to understand the distribution of water that's present on Mars, so that we have those resources to work with. We're also now in the process of planning the first Mars sample return mission, the first time we will ever bring a sample back from the surface of Mars. And through that process, we'll have to learn how and demonstrate the ability to launch from the surface of Mars. So again, thinking and planning ahead towards future human exploration, we're trying to lay that framework and lay the groundwork so that when human exploration is ready to move beyond the moon, we've got that foundation ready to go.
Great. Steve, I know you started to answer that question, but do you have anything else to add?
So talking about the commercial lunar payload services again, we've already awarded the first delivery services to 3 companies. And we're going to be flying as early as late next year and into 2021. And we've already selected the instruments and the technology demonstration payloads that are going to go. So we're off and running with our commercial partners to get this started. And our plan is to fly 2 delivery services missions per year. We're also excited about the fact we are developing a rover that we want to fly to the South Pole at the end of 2022 because mobility is going to be a key asset for science, because it'll enable us to go to many locations and take many measurements and data points within the range of the rover. And in fact, this one, we call it Viper, is going to start doing what we call the ground truth of the volatiles in the South Pole region. Because as Lori mentioned, we're interested in the ice, the water ice that we know is there. Now we need to start going and touching it, right, robotically, and finding out what's the distribution of that water ice. How much of it is it there? And we need to go to several locations, not just one location, to do this ground truth. Because eventually, once we've characterized how much is actually there, then we need to find out how easy or hard is it going to be to excavate that water ice. And you heard on the previous panel about the ability to break the water into hydrogen and oxygen and also use it for drinking water. That'll be the next step. We need to understand how much we can excavate and how can we do that in quantity sufficient to basically support humans on the surface of the moon in a sustainable way. So we've got a lot in the pipeline. When we say we're going back to the moon from a robotic standpoint, we have missions on the manifest. We're working with our commercial partners to make it happen. And so I'd encourage you to stay tuned, because you're going to start seeing more and more of this ramp up here over the next couple of years. I'd also like to add, working with the human spaceflight side, we're actually started working on the first science plan for that mission in 2024. Because we need to start working out what kind of science we would like the crew to accomplish on that mission, and then lay out what instruments are we going to take, right? So that's got to start now. We're less than, 4.5 years away, right? So the clock's ticking. And so we're working with our human spaceflight colleagues to work out what kind of science we want to do on that mission. Astronaut training will come into play as well. Jack Schmidt talked a lot about that, right? So training is key. So all of this is going on now. So we are working till 10 o'clock at night a lot too, Jack, actually, and on weekends. And with the technology today, with email and phones, it's 24/7 pretty much. So all hands on deck.
Thanks, Steve. Appreciate that. So, Jake, I wonder if you could share some about our human return to the moon in 2024.
Absolutely. So within human exploration and operations, I work in the Advanced Exploration Systems Division. So we're really focused on that next generation of systems that's going to enable us to push out to explore new areas. And in this case, that means the lunar surface, and as Lori mentioned, preparing for surviving in deep space and eventually sending humans onto Mars. So we really have this long-term goal that's driving our return to the moon right now. So the systems that we are developing are actually not all that different from during the Apollo mission. We have two major systems. One is called the Gateway and one is called the Human Landing System. And so like during Apollo, the crew were launched, and then there was a separation in lunar orbit of the command module and the lunar module. One crew member stayed in orbit while two crew members descended to the lunar surface. In the case of exploring the moon for 2024, we have the Gateway, which will be basically a destination that the Orion capsule can deliver the crew to. The Gateway will remain in orbit around the moon. It's in an orbit called a near rectilinear halo orbit. It's a lot of words. What that means is this orbit goes around the moon basically in a polar orbit, but it goes out to about 70,000 kilometers. So that will enable us to do research, conduct research that helps us better understand the space environment that we will have to deal with as we move on to Mars. In addition to that, the human landing system itself can go to the Gateway. We need to launch, we believe, 3 separate elements: a transfer element, a descent element, and an ascent element. These elements together make up the human landing system, but they each need to be launched on a separate rocket to get to the Gateway. So instead of having these spacecraft sitting out in deep space on their own, which means you have to design them to support themselves in deep space, they'll dock with the Gateway, and that's where they'll aggregate into the human landing system. So the Gateway itself will not only provide support to the humans who are in orbit around the moon, but to the human landing system until it's ready and the crew are delivered for them to descend to the lunar surface. So it's almost like the Gateway is our command module. We have crew members initially that will stay at the Gateway. We believe 2 of our 4 crew members that the Orion can deliver to Gateway will stay on the Gateway. 2 crew members, at least initially on that 2024 mission, will descend to the surface. So we've been told we will land humans by 2024 in the south polar region of the moon. The orbit that we have for the Gateway enables that to happen. So the crew members that go to the surface, the astronauts that go to the surface, first woman to the moon, next man to the moon, they will descend to the surface in the human landing system. The transfer element will carry it to low lunar orbit. Crew members will then descend to the surface while riding in the ascent element, which means that the crew members actually only reside in the ascent element. So that means that we only need the human ratings for that one element. We don't have to over-design all of the system to support the people. So we can put that on the ascent element. The descent element will take us to the surface. From there, our crew members can conduct surface activities and research. Then they'll return. They'll go back to the Gateway on the ascent element. Then they can return to the Orion once they're reunited with the other 2 crew members and come back to the Earth and hopefully be picked up by a wonderful ship like the Hornet here or Tycho that picked Jack up. So that's the plan right now. And I will point out that this is the NASA design concept study, but we're working, as Steve mentioned, with our commercial partners, and we're looking to them to help us reach these goals. So it may very well be that they have some slightly different designs. So we just want to be very clear, that's our design concept, but we're working in partnership with the commercial partners. Once we get to the lunar surface, we believe we'll be partnering with our international partners as well a good bit. 2024 is that first goal, getting humans back to the moon. But beyond 2024, we're hoping to develop a sustainable presence. So that means we'll be delivering hardware to the surface, maybe habitats, maybe roving vehicles, other instruments, tools, science packages, in collaboration with our Science Mission Directorate. So my job really is to look across this whole plan from the Human Exploration Group and to ensure that the opportunities are present to enable us to do the science that we work on with the Science Mission Directorate. So it's kind of where we stand right now.
Thanks very much, Jake. I hope that those of you from the public are seeing that we're doing this in a different way. The key word here is sustainable. We're involving commercial partners. We're also involving international partners in a major way in construction of the gateway and other things that we're doing. So it's a really different approach than what we did in the 60s leading to Apollo. So now I'd like to open it up for questions, and I want to have a little incentive for any members of the public here. If you ask a question, you get a NASA pin. Anyway,
The Count Survey team members?
Get down to one to do whatever.
we can all have NASA pins. So I don't know where the mic is.
Hold on just a second. I'm seeing if there's questions here. Questions?
Where do we have the roving mic? Here it comes. Oh, okay.
I'll get started here and we'll move down. Okay. This is your hand? Okay.
Hi. In light of today's Robert Mueller testimony, I was wondering about Russia. Is Russia one of the partners internationally that you're cooperating with on this venture?
So we certainly partner with Russia on getting to the International Space Station. They've been a dependable partner for us. They've been delivering our crew members to the ISS, International Space Station, via their Soyuz capsule. We're talking to all of our international partners right now, which includes Russia, but they also have their own plans for exploring the lunar surface as well. So, we are meeting routinely with partners, including the Canadian Space Agency, European Space Agency, JAXA, some of the individual nations as well. That is not my job per se, but I would say that we are looking for a way to establish a sustainable presence on the lunar surface for humankind. And so NASA will continue to push forward to the new frontier. And so when I say that we're going to the moon, we want to go to the moon, do the science we'd like to do, establish that sustainable presence, and then move on to explore and deliver humans to Mars. And so I believe that partnerships will continue to be looked at for how that will be enabled.
I'd like to add to that, and I'm sure Steve will add to this as well, but this is another area and another way in which returning to the moon in this era differs from going to the moon the first time in the late 1960s and early 70s. Is that at this time, there are now a fairly substantial number of spacefaring nations that have a very keen interest in getting to the moon. And you mentioned Russia. Russia has a really extensive program planned to send multiple missions to the moon. Europe is planning a mission to the moon. The Japanese are planning a mission to the moon. The Indian Space Agency just launched a mission to the moon that'll be landing in a couple months. So they're on their way. Israel recently, a privately funded company, organization within Israel, successfully launched and delivered a lander to the moon, almost landed softly, landed a little harder than they intended. But the Koreans South Koreans have a polar orbiter that they're going to be sending to the moon. So we're now talking about, when people start talking about a lunar village and the ability to really enable substantial science and exploration at the moon, we're not doing it alone. We're doing it in partnerships and in collaboration with an entire international community. And I forgot to mention China, which has actually now successfully landed on the moon a couple of times in recent years, and they also have an extensive program to land on the moon. They recently landed on the far side and have successfully delivered a rover that has been driving around there. So this is really an exciting time for lunar exploration, and Steve can add a lot to that, I'm sure.
Well, the only thing I could discussion here. I think that what I'd add is like on the Indian Space Research Organization mission that just launched, we are flying a laser retroreflector assembly on there. On the Israeli lander, we had one on there as well. We have been talking with JAXA about flying that also on the JAXA lander. So the purpose there is it doesn't require power, and it's very lightweight, and it's basically, we want to put one of these on any lander that goes to the surface of the moon, because it basically starts setting up a geolocation network for future landers for navigation purposes. Because you could then laze from another lander coming in and start determining exactly where you're at and feed that into the navigation system. So we've already started these partnerships because now we've already contributed some NASA instruments to those landers, and we're in discussions with our international partners of them providing instruments that we will fly on those commercial lunar payload services missions as well. Certainly, as Lori said, the Russian Space Agency has their plans, and we have been talking. Lori's been talking more so from a science standpoint, but we're open to talking to collaboration activities, not just with them, but all of our international partners, because this really is going to be a global effort from a science standpoint. It's not going to be just the U.S. Certainly we'll start out with U.S. human astronauts going to the surface, but from a science standpoint, we are utilizing a lot of the relationships we've already built and leveraging those, and we're building new ones as well. So very exciting time with the international partnerships as well.
And I think one last key aspect to that is that, beginning of this calendar year, this wasn't the goal that we had before us. So we are all on the international front right now trying to understand everyone else's goals and plans and hopes for the lunar surface. So we're very much in a fluid conversation stage, I would call that. And I think what we'll see is that there will be obvious overlaps. And then as we identify those overlaps based on the planning we're doing now, that's where we can start really talking about how to collaborate towards the goal Lori mentioned about, multiple nations on the lunar surface.
Yeah, I'd like to add one thing as well. First of all, with Survey, international partnerships are really a core part of our institute. And Lori mentioned the launch of Chandrayaan-2, but I really wanted to highlight as well Chandrayaan-1. And in the audience is Carly Peters over there, who was one of the principal people that discovered water on the moon. Would you mind raising your hand, Carly? Yeah, and that was an international collaboration. She had an instrument aboard Chandrayaan-1. So next question, Penny Boston?
Had his hand up.
Thanks. So, thinking about the human exploration end of things, what are we going to do about suits? Because, moving up our human landing aspirational goals from 28 to 24, as we all know, is putting us on a very tight schedule. The Apollo-style suits were nothing if not cumbersome, and presumably we're going to ask our people on the surface to do significantly more rigorous activities on behalf of science and operations in general. So I'm worried about suits. I had a long talk with Stan Love at Johnson, who's of course one of the astronauts, about his concerns about suits. Plenty of people who are going to have to be wearing them on the moon are concerned about this. So do we see a ramp up in trying to get suits ready for this very compressed time frame?
Yeah, that's a great question, which is about suit design and are we going to be able to have a new suit design in place for 2024? And so first I'll answer at a very high level that we're looking at all these systems that way. I mean, we have to design systems to enable us to get to the surface by the end of 2024. Now we refer to that as phase 1 right now, which is landing in 2024. Phase 2 is building towards a sustainable presence on the moon. We recognize that the systems we need to build to make the phase 1 goal are not likely to all carry forward completely through into phase 2. So there is likely to be some aspects, and suits, the reason I wanted to explain that is that suits are likely to be one of these things where we are designing a suit to enable a landing for 2024. Some aspects of that may move forward into a more sustainable and evolvable design that can support that longer stays on the surface. But many of our systems are going to be designed that way. To land on the surface of the moon by 2024, we probably are not going to have full reusability of many of the systems that we are expecting to evolve into a reusable and sustainable system later. So right now we do have plans for developing a 2024 suit, and we're moving forward on that. And the astronauts, as always with anything that they're going to be involved in riding on or fitting inside of or using, they have a good bit of input into how that's going to go.
Great. Two more questions. So one right there, Bob.
Thank you for your panel, this panel, and your perspective. My question is also about sustainability, scaling, and pace. So once we get out to 2028, do you still see reusing the same ascent, descent, and transit vehicles, or is this a whole new set of launch vehicles? And what's the current thinking towards beyond 2028 to when we can establish something that looks like a permanent outpost on the surface, that even if it's not staffed full-time, that they're returning to it and it's an instrument base?
So I'll answer that question. I'm sure that you may all have some thoughts about that as well. Moving out into that phase 2 design, one thing I want to be very clear about is that we expect to be slowly building up assets, collecting science data along the way that help us understand the environment that we're going to be designing to survive in. So it may very well be that we have to over-design to survive in 2024, but as we learn the lessons from the instrumentation, the science communities telling us what that environment is like, we can start to fine-tune the way we're building it. The other critical part to the sustainable phase out to 2028 and beyond is the partnerships that we're going to develop. So, NASA is not envisioning building all of this hardware in isolation of all others. So the question about international participation is a critical one. So we expect that, and from these early discussions, we see that there's a lot of interest to be on the lunar surface. So we're talking about a slow build-up, slow evolution of the systems that initially get us there in 2024. The current concept that we have in place is that that 3-element human landing system study that we have, that the ascent module and the transfer element potentially should develop into reusability. That means we'll have to be testing things like refueling at the gateway. If we can access resources on the surface and use them to help with that, that will be critical. We can test a lot of these things at the International Space Station right now, refueling, reusability. So it really is a complete system from ISS, testing on the ground, the whole way through to the lunar surface, which then itself becomes a test bed for learning how we go onto Mars. And the key to that is the kind of data that we're going to be collecting, because the Human Exploration Operations Mission Directorate really needs that information to help us survive. So it's science value, but it's also kind of an applied science that helps us better design for that sustainable phase later.
I guess pulling on what Jake said too, from a sustainability standpoint, I'll kind of look at it 2 different ways. Robotically, doing science, I think that's long-term sustainability, no question. And particularly if the CLIPS approach is a success and we're able to buy rides to the lunar surface, a couple times a year and go all over, far side, both poles, different areas to do science. I think that is a no-brainer. I think we're going to do that. From a human standpoint, pulling on what Jake said, we have to do that ground truth that I mentioned. We have to see, can we actually execute ISRU, in situ resource utilization, on the moon? And we're going to find out as we go along. If, for instance, we find that it's extremely difficult or it isn't as viable as we thought, we may pivot, right? We may not set up a permanent location. We may do more of a field station concept as we're testing systems to go to Mars. We just don't know right now. We need to learn along the way and learn what we do as we go. We need to get there and get the data to start informing what we want to do from a long-term sustainability standpoint, from a human exploration standpoint on the moon. But again, robotically, I think we're going to be doing long-term science investigations on the surface and in orbit for a very long time.
They've covered everything. I'm gonna we can take another question.
Lori had to
Great.
answer all the
Let's
questions
do
at
one
OPSC.
last question. There's someone in the back there wearing a hat. Gentleman in the hat.
Sir. The question is, at what point are you going to be changing the type of propulsion systems? Because right now I think we're still in the Stone Age. If you want to go way out, even to Mars, you're going to have to get a better propulsion than we have now. It just takes too long to get there. What are your aspects to getting that done? Are there things in the works, or are they still not really there yet?
So I'll start, Jake can jump in. Our Space Technology Mission Directorate has been doing a lot of work in that area. We are looking at solar electric propulsion. We're looking at solar electric propulsion chemical hybrids. We're looking at nuclear thermal. So we are looking at a lot of different alternative propulsion concepts to do the deep space exploration for the long term. That's active now. For instance, and Jake will probably tell you more about it for the Gateway, the power and propulsion element, which is the very first key element that got awarded, is solar electric propulsion. It's not the typical chemical locked hydrogen type system. One of the CLIPS providers, one of the commercial companies that we awarded a delivery task order in the July 2021 timeframe, 2 years from now, they have a liquid oxygen methane propulsion system, which is going to be really the first locked methane system that'll be tested with a lander on the moon. That has shown great promise as well from a propulsion standpoint. So we have started developing new propulsion systems, and we're studying others to actually be able to take us out farther and cut down the amount of travel time for crews as well.
And, that is exactly what we're doing. We have the Space Technology Mission Directorate is investigating that for us. We're trying to do technology demos and investigate new methods of propulsion. That said, Mars is very far away, and that is why we're using the moon and the lunar orbit as a place to begin testing and learning how to survive in deep space, because we can't just make Mars closer, and it is going to be really hard to develop those systems that get us there significantly faster. So we need to understand that space environment. We need to understand how to live out there. We need to understand how crews will operate somewhat autonomously without direct interaction on a near real-time loop with folks here on the Earth. And so these are all things that we're testing, as I mentioned before, from ground tests to ISS, eventually to Gateway as we get there on the lunar surface. We are actively considering how we use all of these as analogs for going onto Mars. So it's kind of interesting, the moon is a scientific, exciting target in its own right, but in some regards it's also considered an analog for us in preparing to get to Mars from an operational standpoint. It's a lot easier to test those things here in the lunar system than it is to just jump straight to Mars and try to figure it out on the way. So at the same time as we work on developing the new technologies that will enable us to maybe go faster, we have to also develop develop the systems based on our understanding of that environment to help protect and enable our crews to survive that trip to Mars.
Yeah, and I'll just say a small, couple of words here, and that's just to concur with Jake, that yes, we need to develop the new technologies to try and go faster than we are now, but ultimately it is still going to be a long trip, and we can't change the light delay time for communications, and so those challenges will remain. And so as Jake says, the demonstration of the capabilities at the moon are really going to help us in preparing for sending humans to deeper space. So that's got to be the critical part.
Great. Well, Thank you all so much. I appreciate everyone staying and listening. I hope you've gotten a really clear message. NASA is really serious about this. We want to go back to the moon. We want to go to all these other destinations. We're doing it in a different way. I'm as optimistic as I've ever been about our future. It's just awesome. So could we please thank our panelists? And to paraphrase Buzz Lightyear, to the moon and beyond. Thank you.